Ladies and gentlemen, please welcome Corporate Vice President, Windows Azure, Scott Guthrie.
Good morning. I'm really excited to talk to you today about Windows Azure. We shipped Windows Azure a little over 2 years ago, and since then we've done a number of nice updates and enhancements along the way. About 2 weeks ago, though, we shipped our most significant release of Windows Azure yet. It really kind of elevates Azure to a new level, opens it up to even more developers and more scenarios, and it's going to really let you build applications that are better and more scalable than ever before. And really excited to kind of have the opportunity to spend the next hour kind of walking you through end-to-end across the new release and what you can do with it. And then there's going to be a number of other great sessions throughout today where you can learn more from a number of other speakers. With Windows Azure, the release we just put out, it's more flexible than ever. Windows Azure historically kind of pioneered this concept that we call platform as a service, and it provides a bunch of managed, scalable services that you can use within your applications. And with our release that we just did 2 weeks ago, we enhanced those services and made that even better. We also, 2 weeks ago, introduced infrastructure as a service as a new core capability within Windows Azure. And this allows you to run durable virtual machines in the cloud using either Windows or Linux. And it's sort of, a lot of people might be surprised to hear the word Linux at a Microsoft event. But Linux is just sort of one example of some of the new openness that we're bringing to Windows Azure. And with this most recent release, we now support more operating systems, more languages, more databases, more tools, and more open protocols than ever before. We're also releasing the Windows Azure SDKs under an open source license and hosting them on GitHub. And we think kind of this end-to-end combination of the ability to use platform as a service and infrastructure as a service together, this ability to bring the best of the Microsoft ecosystem and the best of the open source ecosystem and use them together, really is kind of unique and allows you to build better applications than ever before. Windows Azure is deployed across the world. And so we have multiple data centers spread out across the world. And one of the things that's nice about that is it means that you can, when you build your applications, you can deploy them as close as possible to your customers. Just kind of get a quick look at what a data center looks like. We're going to show this quick video here. Our data centers here have tens of thousands of different servers within them. We have very strong people that work in them. And basically, they're lights-out operations. And so you can basically manage them completely remotely. Everything we're going to be doing in terms of demos today, we're going to be driving these things remotely, and it gives you just a ton of resources and capabilities that you can take advantage of. And they're all super efficient. Wherever possible, use green energy, and again, going to allow you to basically run any type of workload. All of the services that we provide with Windows Azure are offered with a monthly SLA, or service license agreement. And what this means is that you have the confidence when you build and deploy your applications to know that you can offer them to your customers and that they're going to work reliably and consistently as you run them. Other nice thing about Windows Azure, which is a little different than how you traditionally think about software licenses and hardware, is that it's offered under kind of what we call a pay only for what you use model. And what that means is when you deploy something into Windows Azure, you literally only pay for what you use. There's no upfront costs. There's no monthly fee that you need to pay. Instead, you only need to pay for what resources you deploy. And this kind of changes things quite a bit. It means that you can actually start small with very low costs and scale your pricing as your business grows. It also opens up a lot of opportunities for how you run apps in that you can spin up vast numbers of resources for a few hours and then shut them down when you don't need them. And you're only paying for that window when they're available. And so if you're working in, say, a dev test environment and you need a bunch of VMs in order to test your applications, spin them up for a few hours. You can pay only a few euro cents per hour for those. Then when you're done, just turn them off. And you stop paying, and you're able to take advantage of a bunch of resources just for a couple hours when you needed them. Other quick thing, how many people here have an MSDN subscription? Okay, a number of people do in the audience. One of the things that's nice about your MSDN subscription is that it comes with a bunch of Windows Azure resources built in. So if you have a professional, premium, or ultimate MSDN account, you actually already have Azure resources built into that. And so if you go ahead and sign up on Windows Azure and use the same live ID that is your MSDN subscription, you'll find a whole bunch of Azure hours automatically credited to your account. In fact, for Premium and Ultimate, you have enough resources to actually run multiple virtual machines 24/7 throughout the month. And so that's just built in, you can take advantage of. So enough slides. Let's go ahead and actually switch into demos. And let's actually walk through kind of the Windows Azure experience and look at some of the things you can do with it. So what I have up here on the screen now is the Windows Azure website. So this is the live Windows Azure website you can go and check out today. It's got a bunch of information around the different features that are provided with it that you can learn more about. It also has a dev center as well as a management center. And so you can drill into our dev center. You can pick on a particular language that you want to learn more about. We've got a bunch of great tutorials that are included. So you can, everything you're going to learn this week, later on, you can come back and check it out and learn more. We have a one-click installer, so you can install for VS 2010 or VS 2012, and a bunch of great videos. We also for other languages as well. So if you want to develop with Node, PHP, Java, Python as well, we also have one-click installers available not only for Windows, but also for Mac and Linux dev machines, as well as great tutorials that you can check out. For IT professionals and administrators, we also have a manage section of the site. And so you can also learn how to manage and migrate and provision resources and keep an eye on everything that's actually being deployed, also through our manage section. And then when you want to try to figure out how much things cost, you can go to the pricing calculator here. You can choose your currency. It'll automatically set them. I have a US machine, so it's going to be set to US. And you can sort of scale different resources to see how much things cost. So for example, let's say I want to run a Windows machine. It's going to cost me €6 a month to run that virtual machine 24/7 for 30 days. One of the things you also notice on the right is the actual hourly price. So it's 1.3 cents per hour. And because, again, you can spin up and spin down resources dynamically, if you just want to run this for a few hours while you're testing something, it's going to cost you, say, 3 or 4 cents. So that's kind of how easy it is to figure out how much things cost. When you're ready to sign up, just click the free trial button and you can go ahead to the trial page, click the try it free. It takes about a minute or two in order to sign up. And once you sign up, you'll be able to do all the demos that we're going to be walking through today. So everything I'm going to show you this morning, you can go ahead and do using just the free trial. It's a no obligation free trial, so you can try it for 3 months. And at the end of the 3 months, you can just turn it off, or if you want, you can convert it to a standard account and buy anything you want on top of Windows Azure. Once you sign in, once you have an account, you'll be able to go to our new administration portal. I'm going to be showing this off a lot this morning, and you saw this in the keynote earlier at TechEd a little bit as well. But this new portal kind of provides a unified view that allows you to drill in across different types of resources, and we're going to be looking at all these resources over the next hour. It allows me to quickly create different types of resources, so I can create websites, virtual machines, cloud services, and databases, and provides a very consistent way in order to build it. So first demo here, let's just go ahead and build a virtual machine. I could call this TechEd. A few random things there, because I've done this demo once before. I can very easily take advantage of what we call the quick create dialog in order to choose where I want to deploy this application. And set everything up. I can again choose the size of the machine I want to deploy, and then just hit create in order to kick off a deployment. And that's how easy it is in order to spin up a new Windows virtual machine and run it in the cloud. So this is going to provision just for a few minutes. Here's an example of what that virtual machine will look like after it's fully provisioned. This is an existing one that we've already deployed a little bit earlier. You'll notice when you drill into a resource, and this is again true for all the types of resources and all the demos you'll see here this morning, you'll see full diagnostics and monitoring data displayed for it. So I can see CPU, I can see disk activity, I can see network I/O. I can see more information around disks. So you'll notice I have a couple of disks on this. We'll come back to that in a moment. And then when I want to, I can just go ahead and hit the connect button in order to launch a remote desktop session. And literally in a matter of moments, I can go ahead and terminal server into this machine that's running inside Windows Azure, and I have a full desktop experience that I can use for management of the machine itself. And what's nice about the virtual machine capability of Windows Azure is I can basically run whatever workloads I want within it. So this is just a standard version of Windows. I could also run Windows Server 2008 in there. I could also run other operating systems like Linux. And I can install anything I want within this virtual machine. So you can install SharePoint, I can install SQL, I can install BizTalk. It all just works. If I reboot the machine, everything will be there when it restarts afterwards. I'm a full administrator on this box. Other things that you might notice as part of this virtual machine is within the Azure admin tool, I can mount multiple disk drives to this image. So for example, I could just say attach empty disk, give it a size, hit OK, and Azure will dynamically provision a new drive and attach it to that virtual machine. And once I do that, and I've done that earlier with this data disk here, within Windows or whatever operating system I'm running, it'll show up as a drive that I can then format using NTFS or whatever other file system I want, and I can basically copy any files I want within it. And when I do that, that data drive will be persistent, and again, I can use that for any type of storage that I want on the virtual machine. In addition to Windows, I could also create new Linux VMs. And so I can say from gallery, you'll notice here we have a couple of Linux distributions, including CentOS, Ubuntu, and SUSE that I can choose from. All I need to do is click Next, give it a name. I can optionally go ahead and upload an SSH key for authentication. And again, just hit Next again, and it'll go ahead and provision for me a virtual machine using that OS image that I can then go ahead and SSH into or manage. And so, for example, I can click on this VM that we created earlier, which is the Scott Gu Ubuntu image. You'll notice, just like the Windows version, we show full diagnostic information about this virtual machine. So I can see, again, disk I/O. Just like the Windows version, I can attach disks. And so I can very easily attach storage and mount them like I would in Linux. And again, I can format it with whatever disk drive format I want. And we don't have remote desktop with Linux because it doesn't exist. But I can SSH in. And so I could say SSH Scott Gu Ubuntu .cloudapp.net. And when I do that, supply a password, I'm now SSH'd into this instance. I can see what processes are running. I can go ahead and run top in order to see what utilization is on the server. And again, I basically can log in and administer this as a root style account. I can install any workload I want within this VM. Again, it will be persistent, and I can attach any amount of storage I want. And this combination, this ability to create, again, both Windows virtual machines, install anything I want in them, Linux virtual machines, install anything I want in them, ends up being super powerful. It basically means I can run any workload I want within the cloud. How many people here have a network within their enterprise environment? Just about everyone. Wouldn't it be cool if I could take these virtual machines that are running inside Windows Azure and attach them to my network? And that's where this next feature comes into play, which is called virtual private networking. And so one of the cool things I can do is, in addition to creating virtual machines, is I can create a virtual private network that connects, again, my on-premise data center or corporate environment with my machines in Windows Azure, and creates a single a logical network that I can basically link them, the two together. And so I can just name this here TechEd net. Oops. 6. I could Hit next, and what I can do with this virtual private network inside the Azure portal is define an IP address range that I want to use for my Windows Azure resources, subnets, as well as DNS entries. So I can point to on-premise DNS servers that I have inside my firewall, or I could point to DNS servers that are outside the firewall. The nice thing about the address space and subnets is it's virtualized inside the Azure data center. So if you can basically take the IP address range that you use for your internal servers and map it to Windows Azure. And if some other environment or some other company has the same IP address range, you don't have to worry about them conflicting because we'll actually isolate them within the network. So only you can see your machines and only they can see their machines. I'm not going to make you watch me type subnets. Instead, I'm just going to show you one that I've created earlier. And so here I've defined a couple of subnets for machines running inside Windows Azure. I've pointed to a VPN gateway that's running in my existing corporate environment. And behind that firewall, that corporate environment, I have a DNS server that I'm also linking my servers to. Once I do that, I can create these virtual machines and attach them to this virtual private network. I can see data in, data out going across that virtual private network. And then the last step I just need to do is connect this definition that I've created in the Azure portal with my on-premise virtual private network system that I already have set up. How many people here have a hardware-based VPN solution? A couple. If I asked you what kind of routers you had, or if you went back and checked, you're probably using things like Cisco or Juniper or other brands. What we're trying to do with Azure is make sure that we work with all of them so that you don't need to install any software or any new hardware within your network. You can use what you already have. And to do that, all I need to do is define, again, this virtual network topology, click the download button. You can then pick what type of hardware you have, what version of router you have, and then just click the OK button. And we'll automatically generate for you a VPN-specific configuration script for the hardware that you already have installed. Give it to your network operators or network admin. They can look at the script, run it against their VPN, and in a matter of minutes, you can basically link your on-premise corporate network to any number of resources running inside our Windows Azure data center, all in a single net, same IP address range, same DNS infrastructure you already have, in a completely secure, encrypted way. And that's kind of how easy it is in order to kind of expand out your existing resources and start taking advantage of the cloud. So that's a little bit about some of the infrastructure as a service capabilities. Again, the big benefit here is you can run any workload, whether it's Windows or Linux. You can connect it to any corporate environment. You can domain join the servers if you want, or keep them isolated. You can manage them with System Center if you want, or just manage them directly inside the portal. And this ability to kind of connect all of those things, provides a really powerful story. So let's go back to the slides. So I talked again about this sort of flexibility that this gives you, and the fact that it gives you just tons and tons of options, and it lets you use what you already know and integrate that really easily into your environment. A couple other nice things about kind of the way we've implemented Windows Azure that I wanted to talk about. One is the fact that we're using the same virtual machine file format or VHD format that we use on premise with Windows Server and with Hypervisor. And so it's the same VHD file format. And one of the nice things about this is it gives you the ability to reuse all the existing VHDs that you've already created and all the existing VMs you've already created on your own, within your own data center. So you can take any machine that's running on top of Hyper-V, and you basically just take that VHD file, you can upload it directly into Windows Azure, and when you say new VM, you can choose to point to that VHD, and it will boot up on Windows Azure. There's no import-export process required. It's basically binary compatible with what you run in an on-premise environment. Likewise, we could take any of those VMs that we created just a moment ago in the portal, whether they're Windows or Linux, download the VHDs directly from Azure onto a Windows server or even a Windows client device running locally, and then just boot them up. No import-export required. And lastly, there's lots of other hosting providers out there that run Windows. The beauty is you can go ahead and take those VHDs, and if you want, run them in their data centers as well. And that ability to kind of move VHDs seamlessly across all those different environments gives you a lot of flexibility. It ensures you have no lock-in, and it really opens up a bunch of scenarios. A couple other things to talk about. I showed how you could create an empty disk, or again, you can upload an existing data disk that you have. Our disks are in the VHD format as well, and you can mount them on a VM. So that's pretty cool. You can do that in an on-premise environment as well. There's a couple of extra cool things that we're doing with Windows Azure that makes them even more powerful. One of which is that whenever you mount a drive, a durable drive, we're running it not off of a local disk, but rather on top of what we call the Windows Azure storage system. This is a really powerful storage system that has with it a bunch of capabilities. One of which is the fact that whatever you're mounting is replicated across multiple data disks. In fact, it's replicated over 3 data partitions or data drives. The benefit here is if any of those drives ever goes bad, so if there's ever a hardware failure, we've got 2 other copies of your data. We'll automatically, without an interruption, spin up another replica of the third and just fail over to the other 2 while it's spinning up, and your VM never knows the difference. So it basically gives you a way that you're always on, you're staying super reliable, and we also kind of provide much more consistent throughput and disk I/O activity than what you might find with other cloud providers. Other nice thing that is built in as a feature is a feature we call continuous storage georeplication. And what that means is that in addition to kind of replicating your data locally within the data center you pick, we have an option where we can automatically replicate that data to another data center at least 500 miles away. And the benefit there is if a data center ever fails or there's a natural disaster, you have another copy of your data that you can recover from and continue operations. And we basically guarantee within 15 minutes of you writing the data to your local data center, we'll have it asynchronously replicated to a failover location. This is optional, so you can turn it off if you don't want to. We're also careful so that the data centers are always paired within the same geographic or geopolitical unit. So in the case of, say, the EU, your data never leaves the EU. In the case of the US, your data never leaves the US. And again, you can turn this off if for whatever reason you don't want it. But it gives you kind of a nice comfort level in terms of knowing that you have the ability to kind of continue even in the event of a natural disaster. So that's a little bit about virtual machines. Very powerful, very flexible, allow you to take advantage of all your existing workloads in a really easy way. Mark Ruzinovich is going to be doing a talk right after mine, where he's going to go into a lot more detail about virtual machines as well as the private networking capabilities and how you can take advantage of it. What I'm going to do now, though, is switch gears slightly and talk about another new capability that we shipped for the first time 2 weeks ago that we call websites. And what websites do is they allow you to very easily build websites using ASP.NET, Node.js, or PHP. And they allow you to deploy them in seconds. So you can very quickly create a site and then get it live. You can do incremental deployments really fast. And one of the nice things about it is it allows you, the website model allows you to start for free. So every Windows Azure account, regardless of whether you're MSDN or not MSDN, gets 10 free websites. And so you can create up to 10 free websites at no charge, and then optionally switch it into what we call a reserved mode as your traffic grows that provides more dedicated resources and allows you to scale up. And so it ends up being kind of a really powerful model and one that I think hopefully you'll really like. So let's switch back to the demo machine and walk through what that looks like. So I'm going to go ahead and create a new website. And so we'll go ahead and say create a website. What would you like to call this website? Anyone have any suggestions? Silence. No, we'll call it TechEd, and I'll just stick some random stuff there. We'll go ahead and create this website. And one of the things you'll notice about websites is they're really fast to create. So we just created that thing from scratch, only in about 6 minutes, or 6 seconds. So fast, I didn't even know what time it was. Basically, once I create the site, you'll notice we have a very similar view to what we had with VMs, and then we have kind of monitoring data. I can deploy this in a couple different ways. I can set up Team Foundation Server in order to do source control-based deployment. In this case here, I'm just going to download this publishing profile and launch Visual Studio in order to build and deploy this app. So go ahead and do new project. I'm going to create this. TechEd. I can use any type of ASP.NET app. I could use web forms. I could use MVC. I could use web pages if I used Web Matrix. And so I'm just creating this project. This is the Hello World Internet project. I'm going to go ahead and hit publish on it. Import this publishing profile. Hit publish. And Visual Studio now is going to go ahead and start publishing this file. And as it does it, it's going to copy up those files and show me, copy up those files into the data center and upload it. And we should see in a few seconds here, as the site loads for the very first time, our web app. So that was completely end-to-end, creating the site, creating the project, deploying it. Super fast. What's nice about this is not only is it fast in order to deploy the first time, let's go ahead and make a change and see what happens now. So if I go ahead and say, hello, TechEd. Can right-click, hit publish. You'll notice that we support a mode with Windows Azure websites that we call incremental deployment. So it just compared what's on the server with what's on my dev machine. It noticed only one file changed. And so now when I go ahead and do a deployment, I don't need to redeploy the entire app. I just need to deploy that one file. And what you'll see here, again, in about 5, well, less than that, seconds, is the second version of my app has been deployed. The change is live. So it's really fast to create, really fast to do the first deployment, but lightning fast to do subsequent deployments. And I can maintain a very nice change, deploy kind of workflow within my development cycle. What's also nice about this is if I go back to the admin tool and hit refresh, just like we have with virtual machines, monitoring and diagnostic data that we provide, we're also providing for websites the same kind of view. And so we just created our website a few minutes ago, but you can see we're already showing now real-time statistics that are displaying things around CPU utilization in terms of the number of seconds of processing time, number of requests into the site, and data in and data out as part of it. You can go to even more detailed monitoring tab by clicking the monitoring tab, and you can see a bunch of counters as well as both the average and then the max utilization and the total. You can also, if you're a .NET developer, use the System Diagnostics API to build your own custom counters, so like orders per second or total orders, and that will surface automatically within the admin tool as well. So it makes it really easy for you to go ahead and configure and manage that. So that's a little bit where we kind of built kind of Hello World app with .NET. Let's do another app. And I'm just going to say TechEd node. So in addition to .NET and Visual Studio, I can use other tools as well. So I could use PHP. I could use Node.js. And in this case here, I just created a new empty website. And so for this one here, I'm just going to go ahead and show how you can use Node.js in order to deploy it and build an app as well. And with Node.js, I could, one nice thing about websites is you can just use FTP. So if you already got FTP tools and are used to deploying things with FTP, we provide FTP credentials that you can use and an FTP hostname where you can just mount it and use whatever tool you already have in order to upload your code. We also support source control-based publishing. So I could use TFS and wire up a continuous delivery model so that my TFS server automatically builds, runs my unit tests, and uploads the app on each check-in. In this case here, I'm going to show off some of our new Git support, which we also support within Windows Azure. So we just created a Git repository for this site. And what that means is I now have a publishing endpoint that I can use the distributed Git source control system, which is popular with Node.js developers, in order to upload and publish apps with. How many people, anyone here use Git? A number of people. Good news about Git is it not only works with Node, it also works with .NET and PHP. So you can use this, again, across languages. This isn't Node specific. But once I enable Git, I have this little splash screen that explains me how to use it. So I'm just going to launch here. And I'm just going to say TechEd. Create a folder. I'm going to create a simple app. Again, I could write this in .NET or PHP in addition to Node. And what I'm going to do here is just, in the interest of time, copy and paste a little Hello World app. This is the canonical Node.js app if you've ever seen it in a sample. All it does is it's just going to return 200 status code and spit out Hello World every time a request comes in. To integrate with Git, I'm going to say git init in order to set up a local repository. I'm going to say git add and add these files. And I'm going to go ahead and say git commit and say initial check-in. And I've basically checked it in locally. To deploy it then, I'm going to do one extra step, which is I'm going to add what's called a remote to my local dev machine. This is just going to add an alias called Azure that's pointing to a Git deployment node. And then I can just say git push Azure master. And when I do that, it'll ask me for my password. It's going to deploy. Keep an eye on the admin tool on the left-hand side. So we're uploading our app, admin tool, in about 3 seconds. We'll hopefully pick up the change and the fact that it's actually live. And what I should see here in just a moment is that we've deployed our app to Windows Azure. And there we go. Let's click deployments. And that Node.js app is now running within it. So I can go ahead here, click on this, and you'll see, hopefully shortly, a simple Hello World app pop up. Hopefully deployed. And it'll come back up. So, not sure why that. I think someone is actually hitting it from the audience while I was deploying it. So let me try one other thing, which is we'll go ahead and start that one back up. 1 second here. Well, anyway, someone in the audience was, I think, playing with the app before I'd actually deployed it. So we'll come back in a few seconds in order to, or in a few minutes, and it will be there. So anyway, simple way that I can go ahead and deploy things with Git. Again, I can use that with any language. Provides a really easy way for me to go ahead and deploy and run sites. In addition to using Git as well as Visual Studio, I can also go ahead and deploy apps from a gallery. And so I can go ahead and use and deploy directly things like WordPress, Embraco, Drupal, and other technologies directly from within the website. Again, makes it really easy to go ahead and deploy and run things and take advantage of them without even having to write code. So that's a little bit about websites. Let's switch back to the slides and talk about some of the other features that we can use. Oh, actually, one more thing. Let's go back to the websites for a second. One other thing I just want to talk about is everything I've been doing here is using the free, what we call shared instance model of Windows Azure. And so I can basically, again, use up to 10 websites, write them in any languages. I can easily deploy them and upload them, and they'll just work. What I can also do is, if I want to run them not in the shared mode, but rather in a reserved instance mode, I can just go ahead and click this reserved scale tab. I can then go ahead and say, hey, rather than run this in a shared cluster, I want to choose to run this on, say, a couple of medium core systems. So this is 2-core, 3.5 gig systems. I want to run them on 2 servers. And all I need to do is hit save. And once I do that, that will actually cause Windows Azure to go ahead and scale out this site across multiple dedicated VMs that are only used for my applications. And so that's how easy it is to go ahead and build in a shared free mode. And then all I need to do is hit that save button, and we'll go ahead and scale it out and run it inside a dedicated mode that I can use as well. So we go back to the slides. Let's walk through kind of what actually happens on the covers when I do that. So one of the things you'll notice here is by default, again, as I was mentioning, when I deploy these sites using the free model, we're running in what we call a shared mode. And in a shared mode, there's multiple VMs running. Those VMs are used to host multiple customers. And so I have multiple apps running inside those VMs. So again, really nice way from a dev environment perspective that we can try things out. Makes it really easy to use it. I can optionally have multiple shared instances of my apps. So I can scale it out so I have 2 or more processes running within the shared mode. Or I can go ahead, like I showed you on the scale tab there, and spin it into what's called reserved instance mode. And when I do that, I have dedicated VMs that are for use only by my applications. So I can scale up so I have a single app inside a single VM. I could scale it up so I could have multiple VMs running at the same time with that app spread out across them. I can also optionally, if I want to deploy multiple apps in the VMs, I could have multiple apps, but they're only my apps running inside those VMs. And that way I'm isolated from anyone else. Basically just only my apps are running within those machines. And the beauty about all this model is it's seamless. I just click the scale tab and I can adjust it up or down makes it really easy in order to use. The beauty also about this model is because we have that pay-as-you-go model and pay only for what you use, if I scale up or scale down, I can change my pricing dynamically on a per-hour basis. So we pay compute on a per-hour basis. So if you know that you're going to have a lot of traffic tomorrow, you can spin up a lot of VMs, pay for them for a couple hours, and then just spin them back down to one. And when you do that, there's no fixed cost. Again, you're only paying for what you're using, and so it allows you to save money and make sure you have plenty of resources when you need them. So we've talked about VMs, we've talked about websites. I'm going to keep moving on and talk about something we call cloud services. So cloud services is a third model that you can use in order to build applications. And what's nice about a cloud service is it lets you build kind of an infinitely scalable app or service. You can literally have thousands or even tens of thousands of machines that you use within a cloud service. It supports a very rich multi-tier architecture. So whereas websites is focused purely on the web front-end aspect, so it's kind of good for two-tier web database apps. With a cloud service, I can have a front-end as well as back-ends and have a complete multi-tier architecture that I go ahead and take advantage of. And what's also nice about cloud services is it's fully automated. So once I actually build it, I can deploy consistently across those multiple tiers in a very predictable, repeatable pattern. So let's go back to our demo here and walk through a cloud service. So you'll notice here, this is that website that we earlier created and deployed as a website. So it's just my Hello World TechEd. And so it's running right now in Azure as a website. What I want to do is I'm going to add what's called a cloud service project and convert it into a cloud service. And to do that, I just right-click on the website. I'm just going to say Add Windows Azure Cloud Service Project. And when I do that, it adds for me another project into my Visual Studio solution called TechEd.Azure, which defines some additional metadata that I can use to have multiple projects and link them together. And so right now I have a number of what's called roles. Right now I just have one role, which is the front-end website that we created earlier. Let's create another role in my application. To do that, just right-click and say New Worker Role. And I'm going to create what I'm going to call a back-end role, or back-end service, that I can add to my solution as well. And so my front end is just going to basically handle the web UI portion of my app, as well as say the web API pieces. The back-end service is just going to run in the background. Right now, the default template just is an infinite loop and sleeps. But obviously, you could put logic there to process orders, to do any kind of background tasks that you want. And what's nice is by building these roles and by configuring them, I can choose how I want to deploy them, and I can deploy them across multiple machines, and I can scale each one of them separately. So I could say, the front end, let's run on 2 instances of small size. And I could say the back end, let's also run by default under 2 instances. Again, I can choose what size machine I want to deploy. And then all I need to do here is right-click and hit Publish. And just like I did earlier with the website, I can just click Next, Next, and kick off an automated deployment to Windows Azure. Let's go back to the slides, though, and walk through what's going to happen when I do this. So when I click the Next button, so we can go back to the slides. When I click that Publish button with a cloud service, Visual Studio is going to package up my application, upload it into the cloud. Windows Azure, it's basically just sort of a zip file that it uploads that contains all the different tiers. Windows Azure is then going to go ahead and look at the file and say, okay, you're looking for 4 servers by default. It's going to find 4 servers within the data center, 2 for the front end, 2 for the back end. It's going to allocate them, create them, and then it will go ahead and deploy and provision the code within them. And so this will deploy all my application code. It'll also set up the virtual machines. So if it needs to, it'll create certificates in Atom. It'll provision the OS entirely, and it'll make sure the OS image is fully patched. I can also optionally, as part of my cloud service, run a startup task that will provision the VM. So I could install the VM however I want. I can install any custom software I want on the VM as well. I can be full admin on that VM. And once it's finished installing the code, it'll go ahead and wire up a load balancer and expose that application on the internet. And that's fully automated. It takes care of everything. What's nice is Windows Azure will also start monitoring this application. So if at some point a disk goes bad or a machine goes bad or I have app code problems, it will automatically pull that machine out of the network rotation. It'll spin up a new machine dynamically and add it into rotation and then connect it to the load balancer. And the beauty about all this is it does it without you having to do anything. So you don't have to get paged in the middle of the night. You don't have to take any explicit action in order for it to work. That's just sort of built into the model. And because everything is automated, you don't have to worry about a registry key being left around from a previous deployment. We wipe the machines across each deployment to make sure that they're always in a pristine state, so it's very predictable and reliable. So let's go ahead and look at then from a management perspective how you manage this once you've deployed it. So we'll switch back to the demo. Just like I can manage websites and virtual machines inside the admin tool, I can also manage cloud services. And so I'm just going to go ahead and click on a service that I deployed earlier. You'll notice when I open it up inside the admin tool, you have a very similar experience to the one that you saw earlier for websites and VMs, in that you have monitoring data being displayed inside the admin tool, so it shows me the health of the system and a bunch of information around it. I can click on the monitoring tab in order to see even more information about it. So in addition to the aggregate data, I can also add custom metrics. So I could look at disk read throughput, and I could do it both at the aggregate level and at the per node level. So I can see how each individual machine is doing, and then also how my overall set of machines is doing as well. I can also scale these machines up. So just like I could with a website, and I use that slider to control the number of machines, click on the Scale tab, and I can now scale not only the app, but also the individual roles within the app. So if I want a lot of front ends, I can scale it to, say, 300 front ends, and then I could say on the back end, let me scale it to 124 instances. So these are virtual machines. All I need to do is hit save, and then Azure will dynamically rescale the app across 400 machines across the data center. And that's how easy it is in order to manage and monitor the system and then scale it out dynamically. You might ask, was 400 a hard-coded limit? You actually can set the number of cores on a per subscription level. So if you're worried about someone accidentally deploying it across 10,000 VMs, you can set it. And so 400 just happens to be the limit for this particular account. But it basically can go unlimited. And then you can also see how each individual VM is doing. Click on it, and just like we did with the virtual machine, I can click the connect button in order to remote desktop into it and debug it locally if I need to. So a really easy way to manage and monitor your overall service and full administration support for everything. Should also mention with the admin tool, everything we built in the admin tool is designed to kind of make it so that you don't have to write any code or any scripts in order to work with Windows Azure. But the way the admin tool is built is it's actually built on top of a REST management layer. And so we just use REST web APIs to manage everything. And so you can also, as a developer, program against those REST APIs. Or we also have PowerShell as well as Bash scripts that you can use in order to remotely manage it as well. And so, for example, if I say use our Azure command line tool, which is not installed here, but if it was installed, I could basically use it in order to see all of the VMs, basically see the health of each individual machine, and perform all these tasks that I'm doing in the admin tool from the command line as well. And then I could script it entirely as well with my own custom shell scripts. So let's go back to the slides and talk about a few more things. One of the things that kind of, from a meta perspective, that hopefully you've seen a little bit through the talk, is this kind of meme that we like to focus on within Azure, which is this: provide the ability for you to focus on your apps and not have to worry about the infrastructure. So the data centers are managed for you. Everything is automated, either through the admin tool or the command line. And so you can program against it and you can script everything out. And with things like deployments, things like hot replacing disks or hot replacing VMs that are going bad, the system just takes care of that for you. And it's kind of focus on apps, not infrastructure, we think is a really powerful concept that we provide across the overall platform. You've seen some of that already with VMs, websites, and cloud services. I'm going to talk a little bit now about what we call application building blocks, which are an additional set of capabilities that we provide and manage within Windows Azure that, again, also allow you to focus much more on the apps as opposed to the infrastructure. These application services are services we run, so we manage them. We have an ops team that's 24/7 keeping an eye on them. And what's the beauty of them is they provide a lot of capabilities like big data, media, caching, storage, etc., that you can just take advantage of within your app, regardless of whether it's a website, VM, or cloud service. You can use any language with them, so we have SDKs for all popular languages. And we've also open sourced those SDKs on GitHub. So if you ever want to see what the code looks like in order to actually talk to that service, it's open source. You can take a look at it. And then we package up and we ship officially supported versions of them about every 2 to 3 months. So if you also want something that's blessed and certified coming directly from Microsoft, you can do that as well. So let's walk through a couple examples of just these services just so you can get a flavor of what you can do with them. First one I'm going to talk about is called SQL databases. This gives you a way that you can very easily create a SQL database in the cloud. It's a fully relational SQL database. You can use ADO.NET against it. You can use Entity Framework, Link to SQL, or just any type of ODBC driver against it in the cloud. And you can use the same type of SQL Management Studio tools that you use to manage SQL Server on-premise against it as well. So basically, very familiar with what you already know with SQL Server. What's nice is it's a managed service. So we take care of patching. We cluster the database across multiple machines so that you have failover in the event of a disk or hardware failure. We take care of a lot of the administration tasks that you'd otherwise need to manually handle yourself. We also now, as of 2 weeks ago, support SQL reporting services on top of it. And so you can use that in addition to relational storage. So let's see a simple example of how to use this in action. So I'm going to go back to the demo machine, and let's just show creating a new SQL database. So you can see here I have a SQL databases tab. Just like before, I can go ahead and say new SQL database, quick create. I can go ahead and call this TechEd DB, hit create. And what you're going to see here is we just created a database. So that was how easy it was in order to stand up and create a new SQL relational database. So it's created, I can click it, it's online, I can see health monitoring information about it. By default, we just created a 1 gig database. If I want to upscale it to say 150 gigs, just go ahead and hit save, and that will automatically scale up this database to be 150 gigs in size. It's fully clustered, it's fully managed, so all the patching is going to happen for me. To program against it, I can just go ahead and click the Show Connection Strings. Here are the connection strings that I can use in a variety of different technologies. And I can just copy and paste this within my application, and I can now store and manage this database just like I would in an on-premise environment. But again, the beauty is it's just a service I can program to. It's a lot easier to do it. Other nice thing about it from a pricing perspective is I don't actually need to buy anything up front. I can actually just choose what size database I want to use. So if I want a 100 megabyte database, it's €3.55 a month. And basically I can just scale up, and I'm only again paying for the actual storage I'm using, and it's a pay-as-you-go model. And so it's really cost effective, makes it really easy to start for literally almost nothing and scale up as you need it. So let's go back to the slides. Talk about some of the other services that we have as well. So that was relational data with SQL databases. We also support what we call blob storage with our storage system, which allows you to store just arbitrary data. So it doesn't have to be relational data. It can be kind of unstructured data. So you can stick it, think of it like a file system in the sky. You can store any files in there, PDFs, images, CSS, style sheets. You can make them publicly accessible over HTTP. So you can make these endpoints be something anyone can hit, or you can lock it down so that only your applications can access. And just like we do with the drive capability that I showed with virtual machines, we automatically geo-replicate the data across data centers. And to create them, I just go new storage inside the portal. Once I do that, I have a very similar view to what I have with the other services with full monitoring data so I can see the health of the service. Another kind of new capability that we introduced 2 weeks ago is something we call our distributed cache service. And with the distributed cache, it basically provides a low latency in-memory distributed cache. A lot of people here are probably familiar with the ASP.NET caching capability that we ship with ASP.NET. That's what's called a single machine cache. So when you cache something inside the ASP.NET cache, it's running it in memory only for that application and only on that machine. With a distributed cache, you can actually link multiple machines so that you have a single distributed cache so that if any of the machines caches something, it's available to all the other machines as well. The beauty about this with Azure is it's really easy to enable. It can dynamically shrink or grow depending on your application size. So as you scale up or scale down your app, your cache will dynamically grow and shrink with it. It does provide high availability. So anything you stick in the cache, you can optionally say, replicate this on multiple machines so that even if a machine goes down, another cache machine will have it. And in addition to supporting our built-in App Fabric API and wire protocol, so it's compatible with the App Fabric server we ship on premise, we also, with this most recent release, have added Memcached wire protocol support, which means you can take advantage of any existing Memcached client APIs, and it'll just work with it. So let's see a simple example of this in action. So we'll go back to our demo machine. We can go back to our demo machine. There we go. So this is a simple app I have here called the Twitter Reader app. And I'm going to go ahead and launch this. And so this is spinning up for the first time inside an emulator. And what you're going to see here shortly is an application running that provides a simple tweet reading experience. So here we go here. I can choose to search for things on a hashtag or for an account. And what we're doing here inside this app is we're pulling tweet data from the Twitter service and displaying it on the page. And you can see up here the load time is how long it takes for us to load the page. And so we're hitting Twitter each time, so it's taking about 1.6 seconds on each request. What I want to do is, since Twitter sometimes is slow or not available, is introduce a caching layer within my application so that if two people try to access the same cache, I'm not having to hit Twitter in real time each time. So to enable caching and a distributed cache within this app, all I need to do is double-click on my role inside Visual Studio, and there's a new caching tab within this property page, and I can just click the Enable Caching Preview button within that and hit Save. And that's all I need to do. And what this is saying here, and I'll talk about this more in a little bit, this is enabling what's called a co-located option, where the cache is actually going to run on my web server machines. So if I have 4 servers, it's going to have in this case here, about 30% of the memory joined across those 4 servers, and I'm going to have a distributed cache that I can program to. So that's step 1. Step 2 is I'm going to use NuGet, which is the .NET Package Manager inside VS, and I'm going to add the assemblies to enable caching. This just gives me the APIs I need in order to program against it. I then just going to go into my Twitter controller here. Right now, you'll notice I'm always going off to Twitter to retrieve these tweets. I'm going to modify this code so that instead of always hitting it, instead, I'm going to only hit it if it's not in the cache. So first, I reference the new data cache API. I check to see if we've already got tweets for that particular entry. If so, I pull it out of the cache. If not, I then go to Twitter and I add it into the cache for a later return. So that's all the code changes I need to make. Last but not least, I'm just going to update my web.config file to point at my cache server. In this case here, it's the Twitter Reader role that I'm going against. Yeah, I spelled that right. And I'm going to enable this local cache as well within the app. So those are all the code changes. That's all the configuration changes. Let's rerun this app. So we're going to spin up this app again. What we're going to do this time as we're spinning up the application is we are enabling the distributed cache within the individual roles that we're running. And so, for example, here, now when I run this application, first time we're going to go off to Twitter again and retrieve those tweets. But what you're going to notice here on the subsequent requests is instead of it taking multiple seconds, it's now taking less than 1 millisecond in order to retrieve and render that data. And that's because it's stored in the distributed cache. It doesn't actually have to go off to Twitter except every few minutes when it expires from the cache. And I now have a much more responsive application that's also going to work even if Twitter goes down, and it's going to be caching everything offline. So that was how easy it was in order to enable the distributed cache and start using it within my application. So let's go back to the slides and walk through kind of under the covers what's happening there. What's nice about the cache options, I mentioned this co-located capability, and that's what we took advantage of in the previous demo. I just enabled caching at the role level, and I said use roughly 30% of the memory on the system. And when I do that, Windows Azure, when it deploys and runs the app, is going to take the 4 web servers I might be running, take the 300 megs that's allocated to the cache across the servers, and join it together into a ring, which provides 1.2 gigabytes total of available memory for my cache. And now if any code on any of the individual servers sticks something in the cache, it's available to all 4 of those servers to program against, and we provide, on average, about 1 millisecond latency in order to retrieve the cache, even if it has to hop onto a separate machine in order to do it. In addition to this co-located option, we also support the ability for you to have dedicated cache roles. So for example, I could put the cache inside worker roles, and I could have a 24 gig cache, and I could use the admin tool and just say, oh, let's deploy it across two more cache servers, and expand it to be 48 gigs of total distributed cache. And again, the cache will scale up or scale down separately. You don't have to pay anything extra in order to use this distributed cache capability. It's actually just built into the role price. So if you're using the co-located option with your web servers, you've already paid for it. It's not going to cost anything extra. And likewise, if you want to use the dedicated option that I'm showing here, you're just paying the standard price for a worker role. There's no additional license fee or cost required. Again, it provides a really great way that you can very easily speed up your applications and make them much more reliable. Other kind of services that we provide in the app services bucket are identity services. So if you're building an application you want to run inside Windows Azure and you want to integrate it with your Active Directory system or your corporate identity, you can use our identity service in order to do that. You don't even need to. You can optionally domain join your machines. With the identity service, you don't even have to domain join your machines. You can enable single sign-on against Active Directory systems. You can also enable what's called an enterprise graph, so that you can query your Active Directory and pull information from it as well. We also have new capabilities we call like the service bus. And what the service bus gives you is the ability to very easily integrate messaging into your solution. And so it provides a secure enterprise service bus that you can use for queuing capability. It also provides what we call relay. And so you saw me use the queuing capability in the keynote this morning to pump messages back and forth between an on-premise and a cloud environment. Service Bus makes it really easy to do that and kind of enable these what we call hybrid apps. You can do that both with queuing, like I showed this morning, as well as what we call relay. And with a relay, instead of actually sending a message, you can actually connect up a synchronous channel between apps that are running behind your firewall and apps that are running in the cloud. Good example of why you might want to do this is, let's say you have a database that you're not comfortable yet moving to the cloud, or it's running on hardware that you just have already paid for, and so you don't feel willing to actually have to pay for it again in a cloud environment. What's nice is if I do this, I can have this app be behind the firewall, but I can expose a SOA endpoint using WCF to make it available to applications that I'm going to host within Windows Azure. And the way to do that, I just create what's called a service bus relay. I can then have this application behind the firewall connect to it, publish a contract that it wants to make available to applications, and then any of my applications in the cloud, regardless of whether they're running in a virtual machine, a website, or a cloud service, can connect to that SOA endpoint and program against it. Beauty here is I'm not having to open up a virtual private network. I'm not having to provide full access to my network. Instead, I can just publish whatever SOA endpoints I want within my solution and make them available in a cloud environment. And then I can easily go ahead and connect any type of device to it and program against it. So let's see a simple example of this in action. So we switch back to the demos here. I'm going to show off here a simple app where I want to expose some data from a database. It's kind of probably a database you haven't seen before. It's called Northwind. But it's basically, I just got an entity framework model for this database. And what I want to do is I just want to expose what's called a contract that's going to have two operations that's going to allow my app in the cloud to access it. And so this app's going to be running locally on this local machine, and then a cloud service is going to go ahead and connect to it. And so these two contract messages are called get customers and get customer by ID. This is what the implementation of them looks like, so it's pretty simple to implement. I'm just outputting the command line every time they get accessed, and I just use that entity framework model to retrieve the data and return it. And I'm just using WCF to serialize it. So that's the WCF service I created. I'm hosting it using a command line console app that looks like this. All it does here is just connects to Azure in the service bus environment and publishes that service. And if I go ahead now and hit Control F5, this is connected to my local database. It's now publishing that service to Azure. And now anyone I choose to give an ACL to or a permission a token to can go ahead and call this service and call just those two operations, get customers and get customer by ID, from outside my firewall environment. So let's see an example of that in action. So I have this cloud service. Inside here I have this Northwind Mobile. So again, I can manage this. It's running inside the cloud, so it's not running inside my firewall. This is instead running within Windows Azure in a remote data center. What I can do here, again, it's the health of the system. It's not very used, 0.54%. I can go ahead then and, if I want to, just click this URL in order to launch this application and run it in the browser. So again, this is running in the public cloud environment. If I click the Customers tab here, it's going to connect this service back to my local system. And so you can see as I'm loading this page that I'm getting this output here on the right-hand side. So it's getting customers by ID. It's calling get customers. Again, I can go ahead and as I'm navigating through the system, notice that these things are showing up. And so the left-hand side is running in a Windows Azure data center environment in the cloud. The right-hand side is running on my local system and connecting to a local database. And I've basically been able to simply connect the two in a very secure way. So this is ideal, again, if you ever have an environment where you're not comfortable moving a database or apps into the cloud yet, but you'd like to extend them, you can very easily use Azure and use the Service Bus Relay in order to do it. And the beauty is, from a pricing perspective, is if you go back to kind of our pricing meter here, go to the full calculator, you can see how much a service bus costs. Just scroll down. Again, it's pay as you go, so you only have to pay for what you use. You know, if this morning I wanted to send, let's say, 1 million messages in the keynote, it would have cost me, from a euro perspective, 71 cents in order to do that. So that's all it would take for 1 million messages. If I want to open up a relay that I use, the problem is to actually see it so small, I actually have to use the arrow keys in order to do it. But let's say I want to actually maintain a relay connecting my on-premise environment and my corporate environment. You can see here it's basically, if for a full month, maybe it'd be 750 hours, it's only going to cost me about 60 cents in order to keep that connection open 24/7, constant between the systems. So it ends up being really cost effective in order to do. You only have to pay for what you use. Again, provides a really secure way that you can link up the two environments and you can span across your entire enterprise, the cloud, and connect it all together. So let's go back to the slides. We go back to the slides. So hopefully you've seen here lots of building blocks. I've only touched on a few. There's a lot more that Azure provides. You're going to see a lot more show up every month and every year going forward. And again, the beauty is you can use all of these optionally within your applications. Or if you just want to run your existing workloads, you can just stand up VMs and you can run everything within them. So a really easy way to integrate across. You can now use Windows Azure across more than 89 countries and territories around the world. So it's really easy to sign up for. You can get local currency and all these different options. You can basically pay by credit card. You can pay by invoice or an enterprise agreement. And you can also, again, take advantage of those MSDN subscription benefits. So if you're already an MSDN subscriber, you don't have to pay anything at all. And hopefully you've seen over the last hour, and you'll see even more in the talks later on throughout the day, Windows Azure provides a lot. It's very flexible. You can pretty much run any workload now on any platform. It's very open, so you can integrate and interoperate across lots of different systems. And it provides a really solid, scalable environment that you can deploy to, and you can run applications across. And getting started, again, it's really easy. Just go to the windowsazure.com website in order to sign up and learn more. There's a free 90-day trial, absolutely no obligation that you can use in order to actually do all of the demos that I did here this morning with it. And throughout the rest of the day, there's a bunch of great talks as part of this Learn Foundation series that you can attend. Mark Razinovich is going to be next. We're going to be doing a QA over lunch. And then there's going to be another great presentation on Windows Azure websites, as well as one on our data platform and data services that you can attend a little bit later on this afternoon. We're really excited about what you can do with Azure. We're really looking forward to seeing what you build with it. And I want to thank everyone here for coming to TechEd Europe and for this session in particular. And we're looking forward to seeing what you build on top of the cloud going forward. So thanks a bunch and have a great day.